This rule checks for the distance between aggressor via and the victim via, as well as the reference via. Vias are considered a discontinuity and are especially susceptible to crosstalk effects. A signal that is passing through a via on an aggressor net can affect a victim signal passing through another via. In order to reduce the negative effect of crosstalk in such cases, the aggressor via needs to be close enough to the reference via. That provides a good return path for the aggressor. This rule will mark a via as a violation if the aggressor via is closer to the victim rather than the reference. We need to make sure that power ground nets are properly configured, as those nets are used as return current paths. We must also define a victim net object list and an aggressor net object list. Aggressor net object list would ideally contain high radiation nets such as clocks. If no victim list is specified, HyperLynx DRC will consider all the nets on the board as victims except those listed in the aggressor net object list. Along with the victim and aggressor net object list, we need to specify the search radius around the victim vias to find the aggressor via. Being thorough in this setup will help avoid false violations. I am using high-speed IC object list as the victim object list and radiation high as the aggressor object list. Now we can run the rule and see if there are any violations. Let's investigate these violations in detail. Looks like on the address line there is a via that connects signal layer 4 to signal layer 3. Blue via is the victim, red is the aggressor. HyperLynx DRC will search for the reference via within the area of the yellow circle. The radius of this circle is the parameter we defined earlier. This tool also gives suggestion that we should add a reference via within the red circle to minimize the effects of crosstalk and have a more reliable design. In another violation, the reference via is outside the search distance, and we can use simulation to investigate further the effect of the reference via and then decide if the via needs to be moved within the red circle. This way, HyperLynx DRC helps save time by running DRC checks, whereas simulation in this case might have taken a bit longer.